This is the last slide for this lecture, so it's naming wow, I can't talk. Ionic and polyatomic compounds, which can be easy and tricky at the same time. It just depends on what we're dealing with. So the first one, make the ionic compound magnesium oxide. So magnesium, that's your metal, and it's 2+ oxidation number. So notice that the metal stays the same. The nonmetal gets the name change. So that's actually oxygen. So oxygen becomes oxide. So which oxygen has a 2- charge. So I'll crisscross those, Mg2O2, this becomes MgO. So that kind of makes sense. There's only one magnesium, one oxygen, but it gets a little tricky when we'll look at this one here. Lithium chloride, so my metal is lithium, 1+. Chloride, that's 1-. My nonmetal, so that's originally chlorine, but it gets the name change, so it becomes ide. So what I'm going to do is I'm going to crisscross those ones, and it becomes lithium chloride, LiCl. You'll notice that in the third and the fourth one, there's iron in both. However, you'll notice those Roman numerals. Iron, along with copper and some other elements, they're transition metals and they have different oxidation numbers. And it depends on how many electrons, that they're going to lose. So if you see the Roman numeral, so let's look at this really quick. This one, that's a Roman numeral 3, so this is iron 3+. This is iron 2+. So we'll finish the third one first really quick. So I have iron 2+ and oxygen, so that's 2-. I crisscross those, Fe2O2, this becomes FeO. So you can see chemistry is kind of ugly at times. It's muy feo, right? Kidding. The name is going to be iron 2 oxide. So notice I can't just say iron oxide because I don't know which one I'm talking about. If I had iron 3 instead. So iron 3 and fluorine, so that is a fluoride ion. I'm going to crisscross this one, so my Fe has only 1, so I don't need to put that down, and my F is going to have a 3 on it because I bring that down over here. So that's actually my ionic compound with the symbol. So the name, you think that even though you have 3 Fs, that it would be like trifluoride because you have 3. So in reality, because it's an ionic compound, it's just iron 3. Oops, iron 3. That's kind of messed up. Iron 3 fluoride. The next two, you'll notice that carbonate and sulfate, those are considered polyatomic ions. So polyatomic ions means that that particular ion has more than one type of atom attached to it, hence the name polyatomic. So sodium, remember, Na+, so my carbonate ion has a negative charge on it, so that's going to be my anion. So I'm going to crisscross the 2 and this implied 1, so it's Na2CO3. So the name is sodium carbonate. Notice even though there's a 2 on that sodium, it doesn't matter with ionic and polyatomic. Those prefixes don't matter unless it's in the name of the ion, and you'll see a couple of those like that on your list. Last one is potassium sulfate. So potassium is K+. Sulfate ion is SO4 2-. So same process. 2 is going to be brought down here. The 1's going to be brought down here. So this is going to be K2SO4. There's a temptation among students to see the 2 and the 4 and to reduce it. But in reality, you're reducing oxidation numbers. So in that SO4, there's only a 1 on it, technically from the K+. So you can't reduce the 2 and the 4. So this is my formula, and the name is already here, potassium sulfate. So that's it for now. Let me know if you have any questions. This can be a little tricky. So if you need help, please let me know. Feel free to email me or message me on Google Classroom. But yeah, that's it. Take care, guys.